This video here uses questions and examples pulled from old calculus tests. And the first few examples are going to be if you just want to pass your test, and then we're going to move on to some harder ones if you're looking to land in that A range to get that 100%. We're going to start off here with probably the most basic example that there is right here. This one, if you have a nice prof, will probably actually be on your test. Okay, so the formula is going to be, to solve this, it's going to be u times dv equals uv subtract v, or the integral of v du. So in the start of the formula, we have this dv. That means that one of these terms is, we need to take the integral before we can do anything. Our good rule is, wherever you're picking for your u should become simpler when you differentiate. So in this example, we have x and e to the x. When you do anything to e to the x, it just stays e to the x. But when you differentiate x, it becomes 1, which is really simple. So we're going to make u equal to 1. Or no, u is going to be equal to x. And then du, the derivative of u, is equal to 1. And then dv equals e to the x. So then we need to take the integral of e to the x, which just equals e to the x right there, okay? So v equals e to the x. Right here, notice how I wrote everything down. First, I wrote my u, and then I wrote my du underneath it. Over here, I did dv, v. dv never gets used in the actual equation. The only things that get used are u, v, and du. And the order goes like that, and then like that. So your v gets used twice, and your u and your du each get used once. And the reason I write u on top of du is because this gets used first, and this gets used second. So now we just need to plug the numbers in, okay? So first off, we have u times v. So u times v, x times e to the x, subtract the integral of v du, which is just going to be v times 1. The reason we want to make u simpler is for stuff like this. Now it's just x times e to the x, subtract the integral of e to the x dx, which is really just x subtract e to the x, or x times e to the x subtract e to the x plus c. That's your answer. This is probably the easiest question there is for integration by parts, okay? Next question, very easy as well, okay? This is just if you want to pass your test, you need to know these. So u here, simple. What's simpler? What derivative is simpler? Sine or x? Obviously x, it just becomes 1. So du equals 1. And then dv equals sine 2x. So when you take the integral of sine, it becomes negative 1/2 cos 2x. Now, how do I know that? I know it becomes negative because the derivative of anything with the c is negative, and we're doing integration, so it's opposite. And I know we get a 1/2 here because we have a 2 in here. So whatever you have inside just becomes 1 over that. So if it was sine of 2x, be 1/2. Or yeah, 1/2, or if it was sine of 5x, it'd be 1/5. But now we just plug the numbers in. U times v, right? We go like that. X times negative 1/2 cos 2x, subtract the integral of v du. Times 1, okay? So to solve this, I'm going to make it a little simpler. I'm just going to pull the negative 1/2 out, and then we're going to get rid of that. And I don't want to write that again, so we're just going to do this. So now we have all we need to solve now is this right here, and we're done. And so that in the same way of how the sine 2x became 1/2 cos, this is going to be equal to 1/2. The 1/2 I just wrote is this 1/2 times 1/2 sine 2x, and now everything from before. Now let's just simplify this, okay? It's going to be negative x times cos to the 2x all over 2 plus 1 times 1 is 1, 2 times 2 is 4, 1/2 sine the 2x plus c. This next question here is going to be the last one you need to know if you just want to pass your test, okay? It uses a very fundamental trick with integration by parts, which if you've never seen before, it's pretty hard to get the question. You're just going to go like an endless merry-go-round. So right here, it doesn't really matter what we pick for our u or our dv. I personally prefer to differentiate trig, so that's just what I'm going to pick. So u equals cos x. The derivative of cos is just negative sine x, which means our dv is going to equal e to the x, and the integral of e to the x is simply just e to the x. Really nice, okay? So now let's plug everything in. We have cos x times e to the x, subtract the integral of v du. So right here, you can see this didn't really get simpler, right? But what we can do is we can just differentiate again. I'm going to use just a different color to represent that. One thing you have to keep in mind here, though, is at the start, we picked our trig function to be u, which means we have to be consistent with that. If we now made our trig function e to the x, we would be on this merry-go-round forever. So u equals negative sine x, du equals negative cos x, dv equals e to the x, v e to the x. Real simple, okay? Now, a pro tip right here is just always put a bracket here, because it's really easy to forget about the negative or just mess it up, and you'd hate to do all this work and then get it wrong for like a simple negative. But anyways, u times v, we have negative sine x times e to the x, subtract the integral of v du, so e to the x times negative cos x, okay? So what I'm going to do now is distribute. First, I'm going to pull that right out here, actually. So that's going to become a plus, and that's also a plus. And now, I'm going to bring this negative and put it in, okay? So plus, plus, negative. Now we can get rid of these brackets. And if you look at this here, what you can see is this is this. This is what we were trying to solve for at the start, okay? So what I'm going to do is call this I, just I guess I for integral. And then I'm going to okay, so I equals this, right? However, this here is also I. So I'm just going to replace that with I right now. This is simply just like solving for x, but instead we're solving for I. So plus I. Plus I. We moved it all to one side. So now we have 2i equals cos x times e to the x plus sine x times e to the x, right? We're going to divide by 2 now, just to solve for I. So we now have there we go.
Get your plus C. Your prof will take marks off if you forget it.
So I'm just going to do a quick recap of what happened here. Because this question very well may be on your test. It's a very famous integration by parts question. So we started off doing everything simple, but then down here, we had to integrate by parts again. Very important, you have to stay consistent with your choices. If we would have swapped and to start we used the trig for our u, and then down here we did trig for our dv, it wouldn't have worked, and we would have just kept going in an endless loop. So keep that in mind, stay consistent with your choices. If you started with e to the x equals u, that would have been fine. E to the x equals u just would have had to been your second choice again. So we did that. And then the other thing is you need to recognize that once you get to this point where it's the same as the starting question, you move it all to one side and then solve for I. If you're looking to get an A+ on your test, I'd recommend pausing the video and just giving this one a try, okay? This one's pretty simple. It just has a trick at the end or a formula you need to know. But to start off, right, we're just gonna, we could try U sub, but it doesn't cancel out, so it doesn't work. We have to do integration by parts, but there's only one term, right? But we can see there's always a times 1. So this means whenever you see that 2, you have to pick u to be the one term, which in this case, it's ln of x squared plus 3. So the derivative du is going to be 1 over x squared plus 3 times 2x, okay? Now, dv is just equal to 1. So when you integrate 1, you get v equals x. So we have u times v subtract the integral of v du. So we have x times 1 over x squared plus 3 times 2x. So right now this is kind of ugly, so we're going to simplify, okay? We're just going to times the x there times the 2x there as well. So really we just have 2x times x, which is going to be 2x squared. Now we have this ugly mess right here. Like, it would be really simple. It would be really nice if the 3 wasn't there. So we're going to do this little trick in mathematics called write what we want to be there and then find a way to make it true, right? Because this would be really nice if this was just this, and we could pull the 2 out and it just cancel out to be 1, right? So we're going to do that. So how do we make this true now? Well, we added 3, so now we just need to subtract 3. Oh, wait. Negative 3 over x squared plus 3, right? Because in theory, this is all we did. We had x, and then we wrote plus 3, subtract 3. So these two, like, that's the same thing. We didn't break any rules right there. This is all okay. So now, this just all cancels out and becomes 1. So we're going to get rid of it there. We'll move this over. And now I'm actually going to bring this 2 back and bring this negative out. So this is going to become plus, because 2 times 3 is 6, okay? Now here's the formula you need to know. The arctan formula. I'll write this in a different color for you guys here. The integral of 1 over x squared plus a squared equals 1 over a arctan x over a, right? So you may be looking at this and say, like, these two, like, don't really look the same. We don't have a squared here, but we can just take the square root of 3 and write that in. And for this 1, we can just put a 6 there because it's a constant. So I'll go, like, make it a little easier. Oh, that's an ugly yellow. I'm sorry about that, guys. Let's try and change that. So what this really looks like is, I'll write the whole thing out. Times x plus, so this is going to equal 6 over square root 3 times the arctan of x over square root 3. Really cool stuff there, guys. Oh, plus c. Do not forget that plus c. Yeah, but this is a good formula to know because this comes up a lot. Something we're going to have a number over x squared plus something else. And if you don't know this formula, you have to do some really weird stuff to figure it out. So yeah, just write this down somewhere. Next up, for our last example, go ahead, pause the video, try and solve this one on your own. If you do, what you're going to see is no matter what you pick for your u and your dv, you're just going to big mess and it's going to be really ugly. So I'm going to show you what you actually need to do for this type of question. X to the 7th here is really x to the 4th times x to the 3. And then we can see this 1 plus x to the 4th dx. Okay? We can see here we're getting some nice powers that look like they might cancel, right? We have 4, 3, 4. We're going to have to split this into 2 parts to do, like, obviously for integration by parts, but let me show you this. Just this right here is going to be our u. Really simple. du equals 4x cubed. And now all of this, everything else, is our dv. Of 1 plus x to the 4th. So now we need to integrate this, right? And this is going to require a u sub. I'm just going to bring it all down here. The integral of x to the cubed of 1 plus x to the 4th dx, okay? So u is going to, not this, is a new u, 1 plus x to the 4th, and then du equals just 4x cubed dx, which implies that du, or that dx equals du divided by 4x cubed. So now let's sub in all our values. Look at that. Look how nice that is. Cancels. So now we're going to pull that 1/4 out. The 1/4 right here. Yeah, so 1/4. Now it's just 1/4 square root u, which we're going to have 1/4 times u to the 1/2 du, which is going to equal 1/4 times u to the 3/2 over the 3/2, which is just going to equal 1 times 2, because this gets brought up to the top because it's a complex fraction. 1 times 2 over 4 times 3 u to the 3/2. So now we have 2/12 of, let's plug in our value of 1 plus x to the 4th, all raised to 3/2. And then let's simplify 1/6, 1 plus x to the 4th to the 3/2. So this right here that's just our v. That's literally just our v right here. So now we have to plug everything in. So I'm going to take everything we have, copy that, come down here, paste, okay? So remember the formula. U times V subtract the integral of V du. So now we have another whole mess. But if we look at it, we see some nice powers that look like they might cancel. But to start, I'm going to, move this out of the way just so we have some more room. And then I'm going to simplify. I'm going to simplify by getting rid of the 1/6 and the 4. And we're just going to pull those out to the front, okay? I don't want to write that again. So we're going to pull the 4 and the 1/6 out. So we have 4/6 of the integral of 1 plus x to the 4 to the 3/2 times 4x cubed, or times x cubed. We pull the 4 out. And this right here, really simple. Just divide everything by 2. We have 2/3. Really nice. So now, since we can see we have these powers that look like they're going to cancel, we're going to do another u sub. We're going to do u equals 1 plus x to the 4th. So du equals 4x cubed. And I'm just going to solve this off to the side. We have u to the 3/2 times x cubed du 4x cubed. Really nice. Cancel, cancel. We're going to pull this 4 out to the front right here. So now we have 1/4 times the integral of u to the 3/2 du. 3/2, so we're going to add 2 to the exponent. So times u to the 5/2 over the 5/2. But once again, you just bring this 2 up to the top right there, because it is, the formula is a over bc equals a times c over b, okay? For integrals, this is very important to know, but I'm sure you know that by now. Equals 1 times 2 over 4 times 5, u to the 5/2. A little more room, so now we just have 2/20 of u, and u was 1 plus x to the 4th. Now all that is raised to the 5/2, and we're going to simplify this to 1/10. So now, this right here was all of that. So we have x to the 4th times 1/6 bracket 1 plus x to the 4th. And I hate rewriting all this stuff. 2/3. Now we're going to put a bracket here to sub in what we had here, which is just this. Times 1/10. I can't stress the brackets enough, just for not forgetting the little things. Now we just distribute. Yeah, I'm not writing all that again. So it's really just 2 times 1 and 3 times 10. So we have 2/30, which is going to equal 1/15 plus c. And that's it. This was a harder example because from the start, you had to, where to even start? You had to separate the x7th into 2, and then you had to do a u sub, and then you had to do another u sub down here. If you were able to solve that question right there without watching the video, I think you're going to get 100% on your test. If you like the way that I taught this or any of my examples, just check out the first link in the description.